Let's unpack smart contracts, self-executing code that enforces agreement terms directly on a blockchain. Think of them as automated, immutable logic that removes intermediaries, boosts efficiency, and builds decentralized trust. Key ideas include blockchain integration, automation, and tamper-resistant rules, and the strategic implications range from enterprise adoption and new financial instruments to the need for regulatory frameworks and future applications. Smart contracts evolved from an early concept in the 1990 seconds to practical platforms in the 2010 seconds and now broad enterprise interest today. Initial proposals aim to digitize contractual obligations and reduce counterparty risk. Platforms like Ethereum enabled tamper-proof, replicated applications. Looking ahead, the focus is on scalability, interoperability, and integrating advanced technologies like AI. Under the hood, developers translate agreement rules into conditional code and deploy those rules onto a distributed blockchain network, where every node verifies trigger events simultaneously. When conditions are met, matching actions execute automatically, producing predictable outcomes without centralized servers or human intervention, which makes smart contracts ideal for repeatable, enforceable business processes. Security in smart contracts arises from decentralization. Execution records and code are replicated across many nodes, linked cryptographically in ordered blocks, and made immutable by network-wide consensus, so unilateral changes are infeasible. This architecture helps eliminate fraud, guarantee transparency, and enhance trust, while highlighting how important correct design and consensus assumptions are. Use cases span decentralized finance and supply chain optimization. In DeFi, smart contracts automate loans, trading, and yield strategies without middlemen, while in supply chains they can verify IoT sensor checks, confirm delivery, and trigger payment releases automatically, reducing disputes and lowering costs by tying payments directly to provable events. Smart contracts enable programmable ownership for digital assets such as NFTs by executing instant splits of resale proceeds to creators, platforms, and charities. This automated revenue distribution moves beyond static intellectual property, ensuring continuous, transparent value flows to stakeholders without intermediaries, and demonstrating a new model for perpetual and provable compensation. Despite their promise, smart contracts carry vulnerabilities from flawed logic and external data dependencies. Unintended loopholes, reentrancy bugs, and input validation failures can cause immediate financial loss, and compromised oracles can lead to wrongful execution. Effective risk mitigation includes rigorous multi-layer audits, decentralized data sources, formal verification, and active bug bounty programs. The future landscape centers on technical maturation and regulatory recognition, combining advances like cross-chain standards, zero-knowledge proofs, and account abstraction to produce private, yet compliant contracts. Enterprise pilots and evolving legal frameworks will help establish code as enforceable agreements, enabling broader adoption while balancing privacy, compliance, and innovation. At its core, the value proposition of smart contracts is replacing slow, opaque intermediaries with deterministic code that executes quickly, provides an immutable audit trail, and reduces operational costs by eliminating middleman fees. Speed, transparency, and cost savings are the promise, and mastering capabilities plus security practices remains a strategic imperative for organizations in the digital economy.